Right, everyone. Good to see you here. The room is almost full, as always. We're going to start a talk about Tizen RT, which is the lightweight and a smaller brother of the full-blown Tizen for real embedded devices. So this is a talk by Philippe Koval. Thank you.
Thanks. Yeah, it's nice to be here again, all over the years. So yes, I'm a software engineer. I'm working for Samsung. I belong to the European team, and if you have interest into all kind of use cases, demonstration, and if you want to set it up home, feel free to ask me. I will try to help you to reproduce or improve what I'm shared. So first I will introduce you about Tizen and focus about software platform for embedded very constrained devices, and then I will share some tips to get started. So let's go on. There is a lot of content on my slide, so I will just share for you to have a look at afterwards. Not you don't need to read everything. So yeah, Tizen is an operating system that is bundled into many products. So it's in terms of millions of products. We have TVs, we have smartwatches, a mobile phone, which is not as it's a fraction of the market of the mobile phone. It's not that important, but digital appliance, you have all kind of devices, vacuum cleaners. So I will not make the list. We are from open source. So what I want to just focus on, if you look at the support of Tizen, I just listed a couple of devices. They are quite powerful devices. Even if they fit on a watch, it's quite similar to your computer you used a couple of years ago. So there is a part where this operating system doesn't really match very constrained requirements. So what about, so it was branded as the OS of everything, but this, what I've shown previously, it's a Linux system, and probably it will not address every use case. So we have to find a solution to also address constrained device. So there is different class of constrained device, but if you look at the lowest one, it's really constrained. This is less than 10K of RAM, and you have only 100 of K for the ROM. So probably very less powerful than your first computer when you were a kid. So currently Tizen RT is focusing on three types of configuration. Both are also three one are using ARM CPU, and you have the smaller one to the higher one. Probably it's something that will be difficult to bring the full Tizen stack on it. So today I will speak about Cortex ARM R4, which is quite powerful, but not really suitable for the right Tizen. So Tizen is built on the Linux kernel, and the Linux kernel is flexible. It's available on every kind of devices. You have even, I know about people who have managed to make it running on a light bulb, but it's not very efficient in terms of footprint or power consumption. So there are some effort to reduce all the requirements, but we have a different approach. So if you don't want to use probably the most flexible operating system, you have to develop by your own or use an existing operating system. So there are many different kind of products. I will just mention a few which are open source because this is what matters. And if you are considering to move your development to constrained device, I say something which is really relevant for yourself and for your team or your company or your business is the learning curve and the ability for software developer to get into the new operating system, because usually people, once they're comfortable with one technology, they try to fit with it and they don't want to learn everything again and over again. Licensing can be also an important topic. So let me explain about the origin of Tizen RT. So first, it was an internal project in Samsung about different use case about collecting data from sensor on constrained devices, and we were IoT, which is a software stack for seamless communication and seamless connectivity between devices was used. So it was a project that was using IoT constrained devices, and we needed an operating system obviously to run this, and the NetX kernel was used to build this project under the name TinyEra, and then it evolved over time, and it was released to public in year 2016, and then it was rebranded into Tizen RT A afterward. And Tizen RT A is not only the base of the operating system, it's the whole stack where we have a lot of features. So let me just get back on NetX because it's an open source project. It's really inspired by Linux. If you're comfortable with any Unix system, you will feel like home. You have a virtual file system. All your peripherals are accessible through a device, like you can have a proc or /dev, something that you're using on if you're developing on Linux. You have a C and C library, POSIX API. You have C++ support also. Everything is using the new tools you are maybe comfortable with, make files. For configuration, you're using kconfig. You know, when you're building your Linux kernel, you have all the settings you can select. This is the same logic. And in terms of features, there is some support for network, and something really interesting is that you have a different process model because you're not loading the binary and running the executable table. Everything is linked into the firmware, and it's quite configurable. And the requirement for an hello world before somebody asks can be very low, like it's about 16K for just booting the system, and the support of for hardware is quite good. So let's have a look back at Tizen RT A. So this is a wall architecture. So there is some components that have been mentioned in this discussion before, like this one from Benjamin. And I will just go into detail about some feature. So the first one I want to mention is that you can build application on top of the system using JavaScript. So that's quite challenging. And you can, if you're really interested, go to Ziran, my colleague. Where is she? She will talk after, not the next one, but the one after me. So IoT.js is a runtime for JavaScript running on the JavaScript interpreter for constrained device, and this is running on Tizen RT A. So if you know about Node.js and V8, this is something very similar but very constrained. So something quite challenging for Samsung is to make a system that will be reliable on IoT device that's supposed to last not forever but a very long time. So there are some effort to try to change what have been done in Tizen and NetX to add a feature focused on reliability. So there is some rework or redesign of the architecture of the system. One major feature is to try to establish some protection units. This means that you want to separate the user and the kernel land and make sure that the user will not get raw access to the device or something like this, which is can be very dangerous in terms of security. And as the next big challenge is to try to build a microkernel architecture. So I'm not an expert of the domain, but to what I understood, the microkernel philosophy is to try to reduce the maximum of features that can be run in the kernel, and then add services on top of around it to provide all the what you expect from an operating system. So the only tasks that the microkernel which will address was addressing different tasks, giving access to memory and trying to synchronize the world, all the tasks and so on. So if you think about drivers or network stacks, they will not run in the kernel environment. It will be done in a user land. So I don't know if you look at this picture. So in case if somebody goes down and all the network stack is going down, it's only a service which is faulty. So the system should be aware that something is bad over there and try to restart the service to make it available to others. So there is a process of self-healing system when you have some things which are unexpected. we try to recover slowly from this and not reset the system. So if you were at the presentation of one of my colleagues yesterday in the embedded room, he explained something very similar but for Linux system. So you can have an idea about what is self-tolerance and the way to make sure the system will behave as expected. And if for some reason you're losing the control of the system, it's not easy to get it fixed, you have the possibility to update it afterwards. So here comes the next feature, which is connectivity and device management and security. This is really your topic. So there is a lot of feature about connectivity. So there is a lot of different protocols. The main contribution from Samsung on Nutex is to add, and if you compare to Nutex, that we have IPv6 support. So this is bringing on new opportunities in terms of device-to-device connectivities. So your IoT framework has been ported to it also. And cloud feature, and I will not go too back in detail. So one of the mission is to provide the device management framework to Tizen RT, update the device, monitor the device. So this is not yet over, but there are some effort. Security, which is really not my domain. This is really something very specific, and mostly, to what I understood, is done the most at the hardware level. So let me introduce one of the supported boards via Tizen RT. They are not so much, but this one is the reference board. Actually, this is a family of boards. So this one is the one I use for the demonstration. I will show later. So it's an ARM4 core, and it is let's say optimized for real time and reliability. And beside the main CPU, you have some units for security. So there is some specific chip for providing security feature. So there is some, if you compare to Raspberry Pi, that's not something very easy to compare, but something really cool for DIYs. You have a lot of input to play with. So if you want to play with Tizen RT, you have also QEMU support, which can be a good way to get it started. And otherwise, you can try to port to your favorite board. So let's go with, if you boot the system, it will look like this. So you have a U-boot log on the left, and then you have a shell when you can try to run different options, so different commands. So it's really inspired by another operating system you already know. So if you now want to create your own application, first build the system. So all the code is developed on GitHub, so you can get it and eventually submit bugs and patches. And you install the toolchain, and in a couple of commands you configure the system, and you're able to deploy to your board. So next, if you want to create your own first application, there is an Hello World app. You can get use it as a template. So there is no black magic. You will be able to use the regular C include files and try to build your application. Not all the functions may be available. So in case one is missing, you try to find an alternative one, or re-implement one, or eventually port something existing. So if you want to exercise, you can try to create a socket application. That's we will be or port an existing Linux one. You'll see it's the same. So if you want to create a JavaScript application, the first thing you need to do is to enable IoT.js in the configuration of the Tizen RT, and then you have a IoT.js interpreter when you can load the JavaScript and execute them. And if you want to make a standalone application, you just need to create a task that will run on boot, and you can. This is what I will show just now. So if that's the post one get into Tizen RT, I wanted to use it and get fast results, so I tried to make this little proof of concept demonstration. So I was trying to something which is trendy in the let's say IoT, it's to try to collect the data from the environment and to see if you can build something useful out of it to have a positive feedback on it. So the first thing we have to do is to get to know where we are and how can we proceed. So I have working on sensor, just trying to measure the quality of the air, and when I got this result I can try to establish a scenario. So to create the demonstration I've been using an analog sensor. So you have to be careful because those sensors are working in 5 volt. My board is working on 1.8 volts, so you have to make a level shifter and so on. And I created a JavaScript class that is just dealing with the sensor and just producing event to reporting to the system. Next, I want to send an alert to a radio. So I'm not using internet on this. I'm using another network, which is a LoRa network, which is a low power radio. So, but the bandwidth is very limited. But for my case, it was okay. So I use this LoRa microchip modem, and with a couple of commands through the serial ports, you can try to connect to a network and send some value to the network. So then you can get it back on the internet or web front end. I think I can show, yeah. So I recorded a video in case it was not working, but I will just, so what I have here is the devices. So the sensor is there. So this is my home city, Rennes, and I'm using this small antenna to the big one. And if I put some gas on the sensor, then there is a notification sound, you cannot hear here, and then I'm receiving the data on this big infrastructure. So I can show it again here, but I will show you a different view. So okay, so let me just reset the device. So U-boot is booting. I'm just putting some configuration. Now, oh, it's very small. Let me. So yes, can you see it? Yeah, maybe bigger. So here is I'm talking with my modem with TX and RX command. And once I'm joined the network, I'm supposed to be accepted. Yes, that's pretty cool. And just showing some information. We don't really care for now. And this air quality thread is updating the value of the sensor. So I use this lighter, and if it is getting above a threshold, I'm raising alert, and I've been sent just here the payload, which should be received on the other side, but maybe not in this room because there is probably a high run. So let me check. We never know. So here I'm connected to something really new from people I just met yesterday. So I not yet receiving it, but if you check at the time, this was just yesterday from my hotel room. So I have the window open in my room, and it was a bit freezing, but so yeah, if you have some question during the Q&A, you can ask for people from Brussels and Belgium. Those people are doing amazing things. So let's go back to the presentation. Where is it? So yeah, this is an overview about my system. Something I didn't show is okay, we are able to send notification to some antenna, but at the same time, something that could be really useful is to get the position of the device. So, especially if it's a mobile device, so I put my on a bike. This is not a finished product, as you see. And with the phone, you can get the position. You can get the position in a different way using LoRa network. And I have a GPS on my phone, obviously. And I'm using this as a server, and I will share the position to the DIY box. And then I get something more interesting to send back to the network. So here I'm running the IoT server, which is sharing the value of the position. And this side I'm running a client. So this is native code, no JavaScript. And it's discovering the resource on the network and updated in real time. So this is IoT. I didn't speak too much about it, but you will find some resources online. So I think I'm over now. So let's make a short summary. So Tizen, the big Tizen, you can see is based on Linux kernel. Tizen RT is something totally different. Some features of Tizen are ported to Tizen RT. And it's open to developer. You can use it and create application using native API or JavaScript, or eventually port some feature into the platform. And there's a couple of tools, but I'm a command line user, so I didn't show them here. So I think, yeah, some references. All my demonstrations are in my private repository, but it's really in work in progress mode, so I will try to clean it up for you in the future. And now we have a couple of time for questions. Don't hesitate to ask. Yes, thank you.
Yeah, what schedulers does your kernel support?
So if I go back to the question was about FIFO, yeah. FIFO is a scheduler of NetX. This is something I don't know if we are aligned to this or if it's something to be changed, because there is this new microkernel architecture, so maybe some decision made by NetX developer could change. I don't know exactly, I need to check for giving you, and it could change in the future. So it's not something, I cannot really give you the answer you expect.
Some real-time scheduler, right?
Yeah, FIFO is the one used on the NetX. I suppose it's the same currently.
Okay, and just that schedule, you don't have native schedules like other operating systems where you can run round robin with on some priorities or have an ongoing.
Priority is supported, yeah. Yeah. So if what kind of feature in terms of scheduling do we have compared to other operating system? I didn't really investigate that part, so it will be difficult to give you an accurate answer. But yes, there is task and priority and preemption. That's probably the key feature. Leon?
Nice talk. I'm just wondering, what is the long-term strategy for backward compatibility with Linux, and how many patches have been backported from Tizen RT to Linux so far?
From Tizen to NetX. The question is a relationship between Tizen RT and NetX, and it's a long term. Tizen RT developer will invest, will forward their patches to NetX. To what I've seen today, because I cannot predict the future, there are only a few patches on NetX. I suspect that it will occur when the Tiny Ara project happened, but now, technically speaking, it's a fork. So in the future, probably, for instance, board support can be something that will be really interesting to NetX developers. So maybe some community will try to backport it. I cannot speak for Samsung. I don't know exactly the strategy. But in my case, I fixed some. There was a mistake in some application, and I sent a patch to NetX. But yes?
Can you tell us a little bit more about what you've got inside the box? So exactly what's inside the box? You got the transmitter?
Yes. Oh, I can unpack it, but we don't have the time. So yes, I have this main board. Yeah, what's inside the box? So I have this main board, Arctic 055S. I have this, I can unpack it now. This a module called LoRabi. It's made by a Dutch company, no, Netherlands. Dutch. So they are shipping this transceiver from microchip. So with the antenna, it has a XB factor, but I'm not using the socket, so I made the wire by myself. I have the sensor. I'm also using a pretty cool device, which is a software oscilloscope. I'm using this because there is a 5 and 3 volt power output, and for debugging it's also. And I have this buzzer for the sound, LED for the showing, and other stuff I didn't show today. But that's just a prototype. I will probably dismantle it as soon as I'm back home.
All right.
So we're over. Thank you very much.